So as always, let's open a quick word of prayer, and then we'll jump into tonight's topic. So, Lord, thanks for the opportunity to meet and wrestle with these different viewpoints of science and scripture and everything. And Lord, we thank you for the opportunity to expand our minds and our horizons and really wrestle with some difficult topics. And Lord, we ask for your blessing and your wisdom as we go through this. In Jesus' name, amen. All right. So let's see here. A couple of little housekeeping things first. So first thing is that I was talking to Nicole, my wife, and we were talking about how as we ripped through the kind of four different viewpoints, well, the introduction and then the four viewpoints of creationism, independence, partnership, and then tonight qualified agreement, it's a lot to take in, and there's a lot to try to remember, and pretty soon they all start blurring together. And so she had a really good suggestion that I think I'm going to do and take next week, going to do two things that weren't on the original syllabus. So what I want to do first is, last week, Lee brought up a good point in that we did not really cover the young earth version of creationism, the way that the book and the way that we taught creationism was much more from the old earth perspective. It did have a bit of I guess cautionary statements in there about what to be suspect about or what to at least question. But for sake of fullness and sake of fairness, next week what I want to do is I want to spend about half of the time going over the differences between young earth creationism and old earth creationism. They still fall within that first week kind of curriculum, the creationist viewpoint, but just to bring to light the other side of the creationist viewpoint, where they view the view is just different, and especially when it comes to interpreting things like the age of the earth and how we interpret things like the flood, the Noah's flood, and how that could be how that could account for a lot of the geological strata that we see today, those sorts of things. So we'll spend half the time on that. Then I'll spend the last half just doing a recap real quick of all of the viewpoints. So, we'll put all the little Venn diagrams together, all the different things, so we can just get a good snapshot of here's the sort of breadth of viewpoints that we've covered so far. The next week after that, I need to take a break. I want to take 1 week off so I can prepare, and we'll actually be on vacation. And then we'll go back into I think it'll be the probably final 2, maybe 3 weeks of class, which will be a little bit deeper dive on ID or intelligent design. And then finally, we'll dig into some of the scripture and really take a look at, different ways that throughout time, different theologians and scholars have looked through really the creation narrative, the first couple chapters of Genesis, to try to piece the narrative there together with the science that's been going on. So I think that'll be what we'll be doing for the next several weeks. Does everybody think that's a good idea? We're all good with that? Thumbs up if we are, because I can. All right, right on. Fantastic.
Wonderful.
Okay, so we will go ahead and jump right in. So like we mentioned, tonight is the 5th week, and we'll be going over qualified agreement. And so we'll start qualified agreement the same way we've started everything else, where we've got a picture that kind of represents what we're talking about. And in this case, it's kind of the business handshake. It's different than the hands grasped of partnership or independence. It's different than the puzzle pieces of partnership, et cetera. But we're still starting from the same place, which is the place that, going with Hebrews, God created everything from nothing. We believe that wholeheartedly. And the qualified agreement, we still believe that. By faith, we understand that the universe was formed at God's command, and so that what was seen was not made out of what was visible. Creation from nothing. Colossians 1:17, he is before all things, and in him all things hold together. So he sustains everything. So his creation is sustained by him. And then finally, that sustenance, God's sustenance over time, is consistent and ongoing. It didn't just happen and then end, it keeps going. And we see that in like John 5:17. Jesus said to him, "My Father is always at work to this very day, and I too am working." So we have good biblical support for a sound theology of the way that God has participated in creation. We don't know the how, that's what we're debating, and how to engage the two, but worldview stays the same as far as our foundation, our starting point. So what is the sort of takeoff point of qualified agreement? Well, the more that we learn about science, the more that we see that science is actually supporting of a Christian worldview. So in a lot of ways, it seems like it's going to be really similar to the independence view and the partnership view, in that we're trying to almost merge science and scripture, find where they fit together. And rather than the independence view, which is the hot side hot and the cold side cold, and if science appears to support scripture, that's great, but it's not a proof of scripture, they stay separate. Or partnership, where science and scripture are working together towards a common good, and they should have common language and common agreement about, the amount of matter in the universe, etc. QA is a bit more conservative, and it's more of a wait and see approach. And it's actually where the whole realm of intelligent design fits in. So if we look at that from the Venn diagram perspective, it really is a clean overlap, where science and religion, they do have some pieces of area where they overlap. There's still some that are not in solid agreement. However, over time, we see that overlap getting more and more and more. And we'll see that both through the history, where we started out kind of in disagreement, but as time has gone on, and we've learned more and more about science and more about our environment, more about biology and chemistry and cosmology and astronomy, we're seeing that area of overlap just gets a little bigger and a little bigger as time goes on. From here, we're going to go on a little bit of a journey. And it's kind of a timeline of each one of these kind of periods in time where there was a sort of crystallized and understood point of view that the general world basically had. And we'll start that journey in the scientific revolution. So prior to the scientific revolution, really we didn't have a super strong grasp of science. There wasn't this concerted effort to understand our world in a more concrete and explainable way that was coherent with mathematics and as we learned about physics and astronomy, all those things fitting together. And it was an interesting time because it very much was a time of a theistic worldview. And what that means is that God was at the center of everything, and really the search for how stuff worked was really the search to uncover what God had created. And we'll go into it a little bit detail, but the scientists of the time are oftentimes also very devout believers. And so the arguments for how stuff worked were oftentimes theistic in nature. God was at the center of many of those arguments. As time went on, we entered the time of the Enlightenment, it's called. And really during that time, the theistic arguments, that putting God at the middle and the starting place of science being God, kind of fell apart. There was philosophy, there was new science that came out, and new explanations of the physical realm that began to sort of chip and pick at and make less important that theistic worldview. And that really continued until as late as the mid-1900s. Throughout the Industrial Revolution, there wasn't a need anymore for God in science because science was able to, or so they thought, explain everything. And it wasn't until the mid or early 1900s where a couple of new scientific discoveries took place that really shook up the world. It really changed the way people thought. And we had to step back and look at these new findings and figure out what are these findings pointing to. And from the qualified agreement perspective, what we see is that really those findings and what we're uncovering in science is pointing towards the argument for a creator. And then where theology picks up is that it equates that creator with the God that we serve. So that's kind of a written sort of quick timeline. And now what we'll do is we'll kind of go into a little bit more depth on each one of those viewpoints and see, what was the rise of that theistic thinking and what caused it to fall. And we'll move from there. So again, the graph here is you have this theistic argument. That was the early scientific revolution. And there was kind of two branches that folks were using to try to prove the nature of God's existence. They came from the worldview that God existed, but as they did science, as they studied the natural world, they find that they're also going back and trying to prove God's existence through those same arguments. So there's two branches. On the top side, we've got the design branch, which is we're going to be looking at, wow, things have the appearance of design in nature. Perhaps there's a designer. And then on the cosmology side of things, it's the universe and its size and expanse points to a designer. But then each one of those arguments kind of had a bit of a demise, as we mentioned, in the Enlightenment period. So we'll jump into those. So we're going to start with the top row, the design kind of phase of things. And the idea for this was that the starting point for science began with the assumption that whatever was being studied had to be generated from a rational mind. It had to have been designed. And we came to that conclusion because things that humans designed or put together were designed with a rational mind, our skills and our talents. And as we see that similar sort of design in nature, our natural inclination is to push for there to be a designer. Now, the sort of scientific community was right with really strong scientists and famous names who had this kind of worldview, this design argument. Johannes Kepler, John Ray in biology, Robert Boyle in chemistry, and of course the most famous of them all, not Rudolph, but Isaac Newton, math and physics. So Newton has a good quote here that I put down, and it says, "Though these bodies may indeed persevere in their orbits, planets, by the mere laws of gravity, yet they could by no means have at first derived the regular position of the orbits themselves from these laws. Thus, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being." So Isaac Newton, one of the most brilliant humans that ever walked the face of the earth, is saying, yeah, we can explain why the planets stay in their orbits, and we can explain the nature of their orbits, and we can do that with gravity and physics. But what we can't do is understand how they got there and how they established those initial orbits. There has to be an intelligent and powerful being that placed them there. So it makes good sense. You see what appears to be a design. You can't rationally come up with a means to the designed item, the universe, the cell, whatever it is, without relying on an intellect, a powerful being that would do that work. So it's a pretty sound argument. Now, if we go to the bottom of that kind of uh, flow chart where we're talking about cosmology or the origins and nature of the universe, we kind of have a three-step argument. First step, on the left-hand side, we're talking about the universe. And the fact that we are in the universe means that it exists. We can see it. We can, in some ways, measure it. We can study it. We can watch it. We can do all those things so we know it exists. And then also by experience, we believe that the universe is causal, which means a simplification is every action has an equal and opposite reaction, and that happens everywhere in the universe. So essentially, you could posit that all things that are moving or have been moved in the past are there because of a reason. Something caused them to be there. Something caused them to move. Now, at the time, the idea that you could take all of those individual movements and keep going backwards and backwards and backwards in time seemed like an absurd argument. It was just absurd to be able to posit that the causality argument went all the way back for infinity of time. It became this infinite regression, which just wasn't well accepted. People didn't understand it, which meant that the only way to get stuff started was there had to be a first cause. There had to be something that kicked off the process, that put the rest of the universe in motion so that what we see makes sense. It had to have a beginning. And so that first cause had to also have been intelligent for all the pieces to come into place. And so we call that first cause God. So that's how we get to God from cosmology. And then we, like Newton, we get to God through the design argument, in that we see that the nature of design posits an intelligent designer. So we're loud and we're proud. We're in the scientific revolution, and these are the main bodies of thought. Well, as we move into enlightenment, we start to have a problem with some of those thoughts. So we'll start on the top again, and we'll talk about the design argument. Well, as far as the design goes, there's kind of a process, a proceeding that goes on, where on one side, you've got the idea that there's a difference between organisms and artifacts. So an organism is a living thing, and an artifact is something like a watch, a thing that's been created that isn't biologic. It's not it's not an organism. How about that? So as we go through this, you can almost think of it as a thought experiment. These aren't necessarily real experiments. They're just kind of like ways to think about stuff. So Hume, on the left-hand side, he basically said, look, everything that we know in the world that is biology, for example, has its origins in something biologic. So a plant has its origins in a seed, that's biology. You know, a tree, biology. Fruit comes from a tree, which is all biologic. Humans reproduce, biology. You know, it's all there. And so as you go back in time, you would assume that the first cause was biology, because that's the way the world works. As far as stuff goes, an artifact like a watch, for example, you can't compare them to biology. The watches don't reproduce. It's not something that can happen in nature. And so there is another guy, Paley, and he actually puts together this thought experiment that basically says, no matter how much time or effort or correct parts in the universe you have, a watch isn't going to assemble itself. It's a complex item full of lots of individual specific parts. And there's this idea that you can't get it less complex than it already is and keep working. And so that origin of complexity in nature, just like the origin of complexity in a watch, has to come from a designer. And so there's this battle back and forth between this kind of thought process of, well, is a watch, a bunch of pieces, or in one of the previous weeks, we talked about, a tornado ripping through a junkyard isn't going to make a 747. It's just not going to happen. It's the same thing about complexity in nature or this watch. It's not going to happen by random chance. It requires a designer. So in the thought process here, this kind of argument between something that is an artifact versus something that is an organism, and them having basically different rules, it really comes down to the idea that on one side you're saying, okay, a watch, yes, it's got complexity, it's irreducibly complex, and it does show that there had to be a designer. But biology, although it appears to be design, is even more complex than a watch. Watches don't reproduce themselves, biology does. Now, as far as the philosophical argument goes, it was kind of a draw, but what we're going to do is we're going to give it a win for Paley. So that's the sort of design argument. We can say, well, Mr. Hume, you haven't totally made the argument perfectly clear that because it seems like there's design in nature, there couldn't be a designer. So we're going to give that one a thumbs up for the believer side. Now, where design really gets a hard hit is actually in natural theology, or the study of biology and evolution in particular. And this is why. So instead of doing a philosophy experiment where we start talking about, artifacts and biology and watches and stuff, you end up with Darwin. Goes out, looks at some birds, takes a trip on a boat named after a type of dog, and what does he see? Well, he sees that in nature, the science that shows or that appears to look like design. So these birds, for example, appear that they were designed to eat a specific type of seed, and each bird on each island was different. And so it appears that they were designed. But actually, what Darwin posited, what Darwin said is, really, it is just that. It is the appearance of design. We as humans are so driven to put meaning into things and to fill in the blanks that we are willing to say, hey, these birds appear to be designed to do what they're doing, but that is really an anthropomorphization of design. So anthropomorphization is when you take human traits and you put it on an object or something that is non-human. That's why we do that with our pets all the time. Oh, look, the fish is sad. Come on, that's like a human thing. Fishes aren't sad. So what Darwin then posited is saying, no, this isn't design. It really looks like design, but what's happening here is the adaptation of a species through favorable mutation. So this is the selection, natural selection or selection of the fittest. Some mutation has happened that provides a benefit to the host or the organism, and that organism is stronger, therefore that trait gets passed on. Over time, it comes out with a bird that has specifically been adapted to eat a type of seed or open a shell or whatever they do. But it's just the appearance of design. It's not really designed, because there is now this new thinking that mutation plus time and favorable natural selection can lead to a favorable outcome. Okay, so what happens from there? Well, natural theology starts out on a journey that says, well, if we don't start with the idea that there was a designer, and we don't start with the idea that if something appears to be designed, it was designed, and we start looking for other ways that this could have happened, like natural selection, do we really need to include God or a theistic argument into our thinking at all? Now, you can't prove one way or the other conclusively that you either had to have a designer or a God or not, but the way of explaining things and the experiments that they could run and what they were able to verify in nature really pushed this gravitation, this swing towards just a naturalistic argument. You basically can start to explain the known world through very simple, very concise, very believable arguments that don't need to include God. And so, because those are a simpler explanation, a little bit cleaner, you don't have to have this metaphysical sort of thing going on, you can now have this just thrust of thinking that you don't need God. So you can't prove either way. Both are equally believable, but as soon as you don't need to include God, it's a lot easier to omit God. And that becomes the main thrust of science and worldview outside of Christianity for the bulk of the 18th, 19th, and 20th centuries. And really, why we didn't prove that God wasn't involved or didn't exist, the idea of an intelligent designer or a creator behind it was something that was only detectable through your eyes of faith. There wasn't hard proof. If that's the way you believe, so be it, but we can use other means to describe what's going on without resorting to a theistic view. And so really, at the end of the day, the Christian worldview kind of takes that one as a loss. So on the top there, we did design, and now the demise of design, where it was sort of so-so 50-50 on the philosophy, the thinking experiment with the, how complex a watch is versus biology. But when it really came down to natural theology, or the idea that we can explain what's going on in nature without having to use God, that really carried the day as far as scientific belief and scientific worldview. Now, on that bottom track, when we look at cosmology or the history and generation of the known world, the universe, I found this quote from Abraham Lincoln. And, no, Abraham Lincoln was not an Enlightenment philosopher, nor was he the demise of the cause of cosmology, the theistic argument of cosmology, but this quote does fit. So there are no accidents in my philosophy. Every effect must have its cause. The past is the cause of the present, and the present will be cause of the future. All these links are in the endless chain stretching from the finite to the infinite. And so what has happened is that on the cosmology side, rather than the universe having a finite starting point, the idea of this infinite regression has now taken hold as the way things are. If the universe is infinite, meaning it never had a starting point, that it has always existed and it's always gone on forever, as soon as you have that, you don't need to have God to start it. And as soon as you don't have to have God to start it, you don't have to have a creator. And as soon as you don't have to have a creator, you can write him out of the equation and you're free to go on about your business. So between the natural theology arguments for design, and then on the cosmology side, the understanding that the universe is infinite and didn't need to get started or have a creator, it's just always been. Those two sort of grounding statements led the day on all of the scientific and industrial revolution. That's where we were. So the consequences of that type of thinking actually ends up being a little bit, I wouldn't say on the grim side, but it's, to me, a little bit more pessimistic. So one guy, G.G. Simpson, says that man is the result of a purposeless and natural process that did not have him in mind. Essentially, the fact that we are what we are and the fact that we're here is a total accident, and there was no reason behind it at all. Kind of a bummer point of view, if you ask me. So at the end of the day, though, none of the arguments could prove that God didn't exist. They couldn't conclusively say, no, God doesn't exist because of this, but they also realized that they didn't have to. All they had to do was make a stronger argument or a more believable argument that showed that God didn't have to be in the equation anymore. And by doing that, we really had the crash of the idea that design and that there was a creator in the world. It really became the consequence of those worldviews. By doing science that omitted God and making it plausible, we no longer had to have God in science. And as soon as we don't have to have God in science, we don't have to acknowledge God anywhere. It's a rough place to be. So what we're going to do now, before we go on to, the 1900s and later 20th century, where things really change around again, we need to have an aside. We're going to have a logic lesson, which I understand isn't the most exciting thing in the world, but bear with me. We'll see what we can do. Ugh, very boring. So anyway, we're going to talk about a couple different types of logic. So the first one that we're going to talk about is deductive logic, deductive reasoning. And so the way deductive logic or deductive reasoning works is basically if you can make a statement that is 100% true, conclusively true, then anything that you put into that statement will yield 100% true results. Truth leads to truth. Here's an example of that. The statement is that all platypuses are mortal. There's not a platypus out there that isn't going to die sometime. I have a pet platypus, George. Therefore, using deductive logic, I can say that my pet platypus, George, is mortal. Does that make sense? So not the fact that I have a pet platypus, but I had to think of something. So we have a 100% logically true statement. Platypuses are mortal. There's nothing that is not true about that. I was going to use humans, but then you get into the Jesus thing and it just gets weird. So platypuses it is. They all die. I have a platypus named George. Therefore, my platypus will die or is mortal. Totally airtight. There's no question on the premise, platypuses are mortal, and there's no question on the result, the output of that being that my George, he's not long for this world. So again, the only way that deductive logic is solidly true is if that first statement is solidly true. And in the early days of in the scientific revolution, those when we're talking about evidence of God being through design, and Newton, they were believing that they were using deductive logic to prove the existence of God. They were making 100% true statements and yielding 100% true results. The problem was that as soon as you poke a hole in that 100% truth and you say maybe it's a 50-50 truth, deductive logic falls apart. Well, it doesn't fall apart. You just can't use it anymore. It doesn't work. So what do? Well, next part of the logic lesson, we're going to move to what's called abductive logic. Abductive logic is a little bit different than deductive, meaning that you don't have to have 100%. All that abductive logic does is it gives a reason to believe the prior statement or the main cause, even if you can't prove it 100%. Very classic one of this is, if it rains, the streets get wet. That's a true statement. However, if I used just deductive logic on that, I went outside and I look at the streets and I would say, the streets are wet, therefore it rained. Now, unfortunately, that doesn't work. Why doesn't it work? Well, our first statement, if it rains, the streets get wet, isn't the only way that streets can get wet. For example, you could have a burst water pipe, or a street sweeper comes by and flushes the street before he starts his job. So when there are other things that can make the street wet, we can't conclusively say that rain did it. So that's where abductive logic comes in. So we change the wording just a bit, and we say, if it rains, we'd expect the streets to get wet. I go outside, the streets are wet. Therefore, perhaps it rained. It's not the only possibility, but it is a valid possibility. So abductive logic is looking at valid potentials, valid possibilities, and seeing if they fit the bill. So you could say, well, isn't that just a cop-out? Like, couldn't you do that with anything? Oh, the street has paint in it, therefore, any manner of thing, you could make it up. And taken to an extreme, yes, it is just kind of a logical cop-out. You could always fill in the blank with something that might make sense. And that's where we have to take it to this next step. And don't worry, we're almost done with the logic class, so you can wait back up. The idea here is you take abductive logic and you add it to, it's almost like a sense of wisdom. And you end up with what the book and others have called inference to the best explanation, or the method of multiple competing hypotheses. Big, crazy words, but really all it's saying is, when you're using the abductive logic method, let's say this, when it rains, the streets get wet. The streets are wet, perhaps it rained, or the streets are wet, perhaps a water pipe broke, or the streets are wet, perhaps, I don't know, 100 people with squirt guns came out and squirted down the water. How do you pick which one of those three is the best, the right answer? And, or more specifically, of all of the potential answers to the question, which is the one that makes the most causal sense, or which is the one that has the best explanation that fits all of the pieces? Because logic is such a constrained and very focused thing, we have to almost open the blinders up to see a broader picture of what's out there. So for example, causal sense is, we all kind of have a sense of the order of things. We can look at something and say, oh, this had to happen, then this had to happen, and then yes, that is the outcome. it's much less likely that a Rube Goldberg machine made the output happen, although possible. So, for example, let's take a logical statement. We're going to say an earthquake, a large earthquake, may cause a building to fall down. This building appears to have fallen down. Therefore, this building may have experienced an earthquake. Well, is an earthquake the best causal explanation, or is it something else? Well, when we use our brains, we know that, I mean, fast forward in time, we know that the Oklahoma City building was bombed. But using our causal explanation, that power of observation, what do we see? We don't see any other buildings that were affected. So it's unlikely that an earthquake just pinpointed one building. So that's not the best causal explanation. If we were on the ground, we would see a crater. We would see soot marks and maybe pieces of the truck that was used to carry the bomb. All of those things are going to sway us towards the best explanation. We're going to infer from the data which of the abductive logic explanations is the right one. Does that make sense? So it's not that we just have this infinite space of bizarre, weird answers. What we do is we say, okay, here's the possibilities of the answer to why the streets are wet or why this building has fallen down. Now, when we look at them, we use causal explanation. We use which has the best explanation that fits all of the sum of the pieces to explain what has happened. So, logic lesson done. You can wake up, stretch. We won't go back there. And now what we're going to do is we're going to jump, fast forward, to the early 1900s. Albert Einstein comes out, and a couple of things that happen. First of all, a new theory or new Earth theory on how the universe got started, cosmology, takes place. And the idea here is that maybe there was a big bang. There was some cataclysmic event that started the whole thing off. Okay, in theory. But when you add to it Einstein's general theory of relativity, two things become experimentally verifiable. They become provable. And that is, one, the universe is expanding, getting bigger, and it's slowing down. And both of those things point to a point of time where there was a start to the universe. So if the math and the theory point to a start, and the causal explanation is better than an infinite series of time, all of a sudden the universe no longer is infinitely big. The universe is not infinitely old. The universe had a starting point, and the universe is getting bigger. It shows all of the marks of a finite point in time when it started. Cool. Now, as we've begun to learn more about the universe and that we live in, we also start noticing some pretty impressive things. And the scientific or sort of crazy word for this is anthropic fine tuning. And really all that is the incredible amount of extreme balance that is required to sustain life and order in the universe. So scientists have estimated that there are at least 30 individual single parameters, universal parameters, that have to be in nearly perfect calibration and order in order to have the possibility of creating a life-sustaining universe. Now, this balance between the laws of gravity and electromagnetics and planetary motion, all of that stuff, it's the balance of the laws that are in motion. So it's not the laws themselves. It is the laws themselves. It's not the applications of the laws. So it's not like I say, oh, I'm going to take gravity and I'm going to turn it up 2 notches. I'm going to take electromagnetism and turn it down, and now we're balanced. It's the actual ways that the laws themselves work. So it's kind of like when you're in elementary school and you're trying to define a word and then you accidentally use the word in the definition. That's kind of what I'm trying to get across here, is that the balance that we're seeing in the universe is the words itself. The laws themselves are in balance, not just the way the laws are applied. So you can almost think of it like this. Each one of those 30 separate parameters is like a giant knob with a dial on it, kind of like a combination lock. Now, instead of being, 39 little marks on that dial, you can take one dial. You can take gravity, for example, and there is 1 times 10 to the 40th little notches on there. So you have to get it balanced just perfectly to the order of 1 to 10 to the 40th. That's a whole lot of zeros. So now when you take that across all 30 of those knobs, the chance of getting it all totally balanced right, getting that basketball spinning on your finger so it stays in one place, but on a cosmic scale, is approximately 1 times 10 to the 123rd power. That's a lot of zeros. Now, what's crazy about that is if you took every single elementary particle in the universe, every atom in the entire universe, every elementary particle, pieces of the atomic nucleus, there are fewer of those in the world, in the universe, than that number is big. That's a really, really staggeringly small chance to get everything just right. So, pretty unlikely. But that's what science is showing. Now, when we talk about that sort of logic side of things, we can say, well, how could we possibly, if this universe doesn't have enough atomic or subatomic particles in it to give us the chance to get to that number, how can we have enough chances to get to that number that, because we know it exists, right? We're living in it. And so now you get all these wacky theories. Well, what if we had an infinite number or that big a number of parallel universes, all kind of dials turning at the same times? Well, eventually one of them is going to get it right, and that's the one we live in. Well, when you think back to sort of the logic principle, and you put things in and you say, well, what is the most causally likely? Is it more likely that we're going to live in a parallel universe with a zillion other identical but slightly off-tuned parallel universes? Or is it something else? So let's go on. What else have we learned? Well, we've learned some good stuff in biology, especially now that we have things like scanning electron microscopes where we can look into cells and see what's going on. So check this one out. Bacteria, single cell organism that has a flagellum or a little tail. So here's a little GIF, right? See the little guy swimming around? That one little tail to kind of corkscrewing. We can use a scanning electron microscope and look at that thing in great detail. And this is what we see. So in the middle is just an artist's rendering, and on the right is an actual scanning electron microscope. So what are we looking at? You're looking at a machine that's generated by biology that essentially exactly mimics an electric motor. On the very bottom of that motor, you have a stator, and then you have a friction plate, and on top of that, you have a rotor. So now you have 2 things that can move one doesn't move inside the cell, and then on the top something else moves, and then around it, in those kind of pinkish purple things, you have some proteins that can actually cause that whole assembly to spin. And then as you move up through the cell, you actually have a set of bearings and gaskets for that tail to come out of. And all of those things working together is what makes that tail go round and round and round. It's just like an electric motor. So think about it this way, though. This is kind of an interesting, thought experiment. If in Darwin's world, natural selection works by selecting functionally advantageous mutations in a system, and then selecting those to be reproduced, at which point another mutation can happen, so on and so forth. Well, for this motor to work, this motor has over 40 individual parts in it. When you take apart all of the little proteins that make up the gaskets and the bearings and the stator and the rotor and all of the parts, there's 40 individual parts. You take one of those parts away, motor doesn't work. So how do you get from there to here? I mean, the odds that in one mutation you get 40 working parts that are all working together like a motor is ridiculously small, stupendously small, infinitesimally small. Something to think about. So, more biology. Well, we know about things called proteins. Proteins are one of the most important and useful building blocks and cellular engines that we have. Originally, proteins were thought of just a really simple, regular structure in the cell, something very simple, some chain of amino acids. Well, as we began to really understand protein, especially proteins in cells, we really started to get our minds blown. Rather than being a simple, regular structure, as it turns out, proteins, this is a growth hormone protein. Proteins are weird. They are three-dimensional structures that have complex and really organic geometry. Even weirder than that is that bizarre shape is like a key to a lock. That one specific shape, that three-dimensional protein, is like a three-dimensional key that can plug into a growth hormone receptor and make something happen. I mean, the complexity of those two things working together on such a small level is mind-boggling. And then when we're going to ratchet it up one more, and we're not going to go much into it on this particular topic today because we'll talk about it more when we go into ID as its own class, you look at DNA. I mean, DNA makes the complexity and depth of DNA makes everything that we just talked about seem like child's play. DNA is wickedly complex stuff. Bill Gates, the founder of Microsoft, is quoted as saying, DNA is like a computer program, but far, far more advanced than any software we have ever created, from a book called The Road Ahead. So DNA is crazy. So what does that lead us to? How does that get us anywhere? Well, if we use our competing hypothesis idea, or that inference to the best explanation, what is the best explanation to support each of those previous items that we looked at? The flagella in the bacteria with the 40 parts that have to work together, any one of them isn't there, it doesn't work anymore. The complexity of DNA, the extreme three-dimensional shape and structure and keying of a protein, the anthropic balance of the universe that requires more chance to get it right than there are subatomic particles in the known universe. What is the best explanation? Is it time and chance? Is it those wacky parallel universes? Or is it something else? An intelligent designer? Well, if you're me, you're going to put your money on the ID, the intelligent designer. Now, in the purest of the intelligent design arguments, all we are able to do is show that through inference being the best inference to the best design, the best way to understand each of these wickedly complex and radically specific elements in our universe is to conclude that something that is much more powerful and outside of our space designed those things, designed us. That does not talk about the character of, the nature of, or the will of that intelligent designer. So we can go so far as to, with intelligent design, say there was a designer. It's so in that kind of overlap of the Venn diagrams, that middle part with intelligent design can say, yes, both science and theology or Christianity, where they overlap, we're going to agree that there's an intelligent designer. Science isn't going to have anything to say about the nature and character of that, but that's when the Christian is like the kid in the back of the classroom, pick me, pick me, pick me, I know what the answer is. And that's because we can fill in the rest of the blanks, because we know who the intelligent designer is. And so wrapping up for tonight, back to the logic, sorry, we can make this abductive logic statement. If theism and the Judeo-Christian view of creation are true, then we would have reason to expect a finite universe. We have evidence of a finite universe. Therefore, the Judeo-Christian view may be true. We can't say that it isn't, but we can certainly use our abductive logic and inference to the best explanation to show that the Judeo-Christian view is a strong contender. If theism and the Judeo-Christian view of creation are true, then we have reason to expect evidence of intelligent design in nature. We believe that our God is a God of wisdom and creativity, and we would expect to see that reflected in nature. Nature appears to have designed-in features, things that are irreducible in complexity. Therefore, the Judeo-Christian view may actually be true. There's good, logical, inferable evidence to support that. And that abductive reasoning and inference to the best explanation can go on and on and on. And suddenly now we've built up this body of knowledge that suggests, at least on the science side, that an intelligent designer is a reasonable conclusion to why things are. And then it's just the step of us, the evangelists, the Christians, those who know that creator, to push them one more step to say, this is the creator, this is the designer, let me introduce you. And so that, my friends, is all I've got for this evening, a little bit shorter tonight, closing at 8 o'clock. So do we have questions on qualified agreement? Comments? Bueller? Anybody?
Definitely makes you think about a lot of different things.
Yeah, no, it really gets kind of wacky in there when you start thinking about all the logic and deductive and abductive and all sorts of crazy stuff. So it's a lot to take in, which is why we'll do the quick wrap up next week, next week.
Matt?
Yes, sir.
I'm trying to figure out where you got a couple things. With the advent of studying of dark matter and dark energy, they found that the universe is expanding, but I don't think they found that it is slowing down at all because of the dark energy.
Okay. Okay. I'm not super up on my dark energy.
Well, they found out that 2 or 3% of what we see is visible energy and matter. About 27% is dark matter, and the rest is dark energy. Because where they're having a problem, because the dark energy will cause it to collapse, but the dark energy is more powerful. They don't even understand what dark energy is, but nor do they understand what dark matter is. But the universe seems to be expanding, which doesn't mean it's not finite. It's finite as far as it goes, but I don't think it's slowing down.
Interesting. Okay. Well, good to know. I did not know that.
Dark energy being fairly new. I remember when I was growing up back in high school, that was a major question. Dark energy wasn't a word then, but the major question was, okay, we see, we think the Big Bang, and we see the universe expanding. The question is it going to continue expanding forever, or is it going to come back down and collapse again? And that was a major question that people were looking at, and scientists were looking at. And I do remember them coming out with, and of course I didn't read into it, the conclusion at that time was that it will not continue expanding and that it will start contracting. Now, of course, new theories and new discoveries, dark energy and so on, and that energy's in that word. I don't know what the latest theories are, but that was the conclusion back in the 70s.
Yeah.
Well, they
the
argued
universe
because
expanded and it would come back.
Yeah, they thought the universe was going to stop and come back into a Big Bang, and then the scientists says, "Oh, there's not enough matter," and then they found that how come it's doing was they found dark matter. Then he says, "Okay, that it is going to collapse," and then they found dark energy. And it shows that they don't know how under the forces of dark energy it is going to expand, and it shows no sign of showing down. So
I thought you were saying forces of darkness for a minute.
Who knows? Ba, ba, ba. No, it's astrophysics, and theoretical astrophysics is wacky stuff. I mean, it is super hard to comprehend, and there's no doubt about that. But I do think that one key takeaway is the finite beginning. That is actually a pretty earth-shaking and core-rocking understanding of the way that astrophysics works. Because that turned the world of physics, of astrophysics, of cosmology. Cosmology. I got to make sure I don't get that confused with cosmology. It's a big difference. I mean, one's universe and the other's make it. Turned those worlds on their head, and it really shook stuff up. So it's a big, crazy universe out there. All right. Anybody else?
I'm not going to worry about it right now. I can't control it anyway.
Yeah, exactly. There is definitely that. There is the at some point, and I guess maybe that's kind of just a personal mindset. There is that kind of person that's like, I don't understand it. It doesn't really affect my day to day. Kind of cool to hear about it sometimes, but I'm not going to sweat it because, And then there's the person who's like, but it's my life's work. I love it. I need to know more. And that's the way God makes us. Is we each have different interests and things that drive us in our passions. It's cool.
I do have one prayer request.
Sure.
I don't know how I did it, but about 4 weeks ago, I got a lot of pain in the knee. I think it's a ligament pull. A few nights I couldn't sleep because of the pain, and right now I'm icing it and wearing a brace, and hopefully it'll go away because I can't work out with that the way it is.
Yeah. Okay. Yeah. I'm happy to pray for you, Tony. All right, gang. If there's nothing else, we'll call it a wrap for this evening, and we will catch up with you next week for a quick recap of what we've done for the 4 different viewpoints, and we'll add into that some of the specifics about young Earth creationism. And yeah, so we will see you guys same bat time, same bat channel next week.
All right, Matt. Thank you.
See ya.
Thank you.